Great. Hello, my name is Vickenty Fesunov, and I write Perl code for Booking.com. If you haven't heard, we're hiring. So if you're in the market for a job, come talk to us. But this is not about my work at Booking. This is about something completely unrelated. It's about this new shiny programming language called Rust and how it can work with Perl. So Perl interpreter itself is written in C, as you probably know. And naturally, this makes C a great choice for writing Perl extensions as well. C is a great language, very powerful, but with great power comes great responsibility. Where Perl has runtime checks to make sure everything goes all right, C just assumes programmer follows the rules and continues. For example, when you dereference a value in Perl, Perl checks that it is defined and points to a valid variable and generates a runtime error if it don't. In C compiler just, okay, it will be fine when the program runs. If it doesn't, well, something happens, but it doesn't tell you what. And this is a lot of this stuff in excess as well. So a lot of functions return null pointers. Dereferencing a null pointer or passing it to a Perl function is not good. So programmers must be very diligent and check everything before using. C doesn't have reference counting, unlike Perl. So programmers must be really diligent and track every memory location they have a pointer to and make sure it points to a valid location. And there is no way around it to check this at runtime, actually. You just have to be very careful about it. You also have to keep track of size of every memory location you have a pointer to. Otherwise, you risk writing past the end of it and overwriting something you don't expect and crashing a program 5 minutes later when your code finished running. And there is a lots of these rules. The list of these rules in the language standard takes 15 pages, so it's a lot. So I'm not trying to say that C, excess, or Perl itself is wrong or bad. There is a lot to worry about when writing C. And these bugs are not just crash your program sometimes. They cause serious security vulnerabilities. So we just have to be very, very careful. And Perl itself doesn't make things easier. What does this function return? What do you think?
Last element in an array.
Yes, it calls length, but it returns index of the last element of the array. Perl has reference counting, but it doesn't count every pointer as a reference to be fast. So C programmer must be careful and do different things to the same pointer in different situations. Perl has exceptions, C doesn't. So if you have objects that need to be explicitly released on the stack, you have to guard them against exceptions in Perl, otherwise you leak them. And all this like huge pile of small things you have to keep track of, and they're all very dangerous. And being careful is just not enough. We have lives, we have coffee shortages. We have to be very, very careful, and that still leaves bugs and vulnerabilities and crap. So Rust is a new programming language that is basically built around the idea that being careful is not enough. It is compiled, statically typed language that is binary compatible with C. So by necessity, it must be able to do all the same things that C can. It can do pointer arithmetics, it can have structures, it can cast pointers between types, and it can read and write arbitrary memory locations. This is something you cannot do in Perl, because Perl takes care of it for you. But the idea is, and unsafe code is very frequent in C programs, so we think it will infect the entire programs and there is no point in a different language. So what Rust has a lot of features to prevent this spread, either to make unsafe code completely unnecessary, or at least to contain and move it into some kind of safe abstraction. So this is something not a new idea, actually. The Perl itself can be viewed as a safe abstraction around unsafe C code, but with a different kind of guarantees that Rust has. And Perl Access API also has that. SV internally is composed of different structures that are used in different situations, but Perl Access API handles that for you, so you don't have to worry about it will do the right thing for you if you just stick to the API. So this is idea that Perl access package in Rust tries to do. It tries to abstract away unsafe details of Perl access API behind like some kind of safe high-level abstraction. And the basic idea that Rust programs, whatever they do, they may be completely wrong, but they should not be able to corrupt Perl interpreter state or crash the interpreter. So let's write some code and see how it goes. Things you see on the screen with bang at the end are Rust macros. They transform source code, and access macro takes care of low-level details of how actual binary function should look like. It tailors it to the running Perl version. It uses some kind of Perl syntax, like pseudo-Perl syntax, to set things up. Access return is a macro that takes a variable number of arguments, pushes them to the stack, and returns all in one line. All subroutines in Rust access accept one argument, context, that is a window into the Perl interpreter itself and to the argument stack. So from that stack, we can pull the argument, and the istFetch function will check if there are enough arguments on the stack and die, because it has to. But we also could check manually and return and die with a more user-friendly error message. We try into some elements of the array, so our argument is an array reference, and we need to dereference it before we can get to the elements. But wait, this is wrong. What if the param is not an array reference? So this program does not actually compile, because deref AV returns something that is called option. It is a replacement for null pointer in Rust, basically. So but instead of being in band, it wraps around the actual value. And to get the value, you have to unwrap it. So you have to check if it's defined or not. And it is not the value itself, so you cannot use it as an array. It's just an option. There are many ways to do it. One way is to use one of the many methods that it provides, and this is Rust equivalent to common Perl or die idiom. So you just write, if it's defined, use it. If it's not, die. Next, we need a counter to hold our values, and a loop to go over the array elements. Type annotations in Rust are optional. It can infer types of most variables automatically inside a function. Then we just pull elements from the array one by one and add them to our accumulator. Now, AV fetch function in C can also return a null pointer. So array fetch in Rust returns option as well. Here, we just check explicitly if it's defined. So this can be read. So this if statement can be read if defined my item equals something. Then we just add it to the accumulator. Array fetch can also convert SV to a primitive type, and because it happens exactly after we pull element from the array, we can do it without manipulating reference count of the SV. I forgot to mention that every SV that you have in a local variable in Rust has to be reference counted, because otherwise it can go away by calling Perl function or doing something, and you have a memory problem. So that's it. This wouldn't be complete without benchmarks, of course. Now, when I was writing these benchmarks, I expected to see that Rust code would be slightly, maybe not slightly, but slower than XS, because it has to jump through more hoops, and there are some inefficiencies inherent to the approach. But what I didn't expect to see is that it would be slower than Perl itself. So what's going on? Remember I said that C doesn't have exceptions and you have to check for them? That's what I did in the API. So there is a try-catch basically on every line of this program. Every call to Perl access API can die, so we have to check for exceptions to unwind through Rust code and clean up the reference counts it has on the stack. Now, this is not strictly required for memory safety. Leaks are bad, but they don't cause security vulnerabilities. They just, like, your program stops working at some point. So it's bad, but not that bad. So maybe there is more freedom in how to handle this, but for now, let's just disable them and see how it goes. And it goes much better. It's still slower than XS, about 2.5 times, but at least it's faster than Perl and it's safe. Another benchmark I did is to compute greatest common divisor. It doesn't use Perl access API that much, it just gets to arguments from the stack, does some simple math in a loop, and returns an integer back. And it works faster, even so that doing computation in native code outweighs the horrible overhead of doing it in Rust. And without exception checks, it's actually pretty decent and only slightly behind CXS. So, what we can learn from this? It's possible, it works. It's not pretty maybe, but it works. It's safer, there are no pointers in the program whatsoever. We have all bases covered. And it's slower. Well, it was predictable. So that's it. Any questions?
So how do you compile this and then access it from Perl?
So this program compiles down to a shared library, just like access. It has the same binary interface that access library would have, so Perl can just load it with a dyno loader. It doesn't know that it's written in Rust. And there is a small tool chain built around it, so you can build the program using Perl tools. It just dispatches to Rust compiler instead, and then puts the files in the right locations.
So I noticed that you have access bang there, and then stuff that looks like Perl, and then within the subroutine is actually Rust code.
Yes.
How is Rust equal? Is that part of the? How is it distinguishable between the two there?
So it's quite actually simple. Rust macros can match on the token tree. So it just expects to see package and some identifiers, and then it's sub and name and context, and then it just expects to see some code block. So code block is just matched as Rust code.
If you distributed a module using this, what would a person need in order to use the module? Do they need to have Rust installed?
Yes, to build the module, you need to compile a Rust compiler installed, and you need access to internet to download the package. But to run it, you just need the final binary.
Because again, the binary is the same API as C.
Yes, exactly.
Something compiled in Rust, and you drop it on your system. And
Yes.
Yeah, okay.
So in other words, to use CPNM, you would need to have Rust installed. But if you had this in like a Debian RPM or a Dev package or an RPM, then it would just be pulled in like a binary equivalent.
Yes, exactly. Oh, I think we still have time, so maybe I can do a demo. Let's see how. Okay, there is a shell. So and we're in the right direction. There is some. So we have a couple of files. Here we have a makefile.pl, which is normal Perl build script. We have a Perl package that just calls access loader to load the package, and we have the library. So it's exactly the same code that I was showing before. Makefile uses module install, which I made a plugin for to build actually Rust code. So we can just say makefile, and then we can follow the same path. So it downloads and builds some stuff. And it builds the program, so it puts the final binary into the location where Perl expects it to see it, and we can just it works. So there isn't much going on from the user perspective, but it's more or less hidden. All right, thank you very much.